We have another example on the board. First, we have to find the impedance of the inductor. In other words, we have to find the inductive reactance. Because we have given omega, okay, I can use the formula which says X of L is equal omega L. Of course, you can say that this is J omega L. So this is equal 1 times 10 to the 6 radians per second, right? I can put J, times L, which is equal 50 microhenries. So X of L is equal 50 ohms, I can say J 50 ohms, or I prefer to use polar form 50 ohms and angle of 90 degrees. So this is X of L. The problem is asking me to find total admittance, conductance and susceptance. Because I have already X of L, I can find BL. BL is equal 1 over X of L. So I have 1 divided by 50 ohms and angle of 90 degrees. This is equal 20 millisiemens and angle of negative 90 degrees. This is my inductive susceptance. Next, I can find the conductance. So I have G is equal 1 over R. I have 1 divided by R, which is equal 20 ohms. This is equal 50 millisiemens. Next, I'm supposed to find Y total because I have found BL and I found G. So the formula says Y total is equal, total admittance is equal G plus BL, which is equal 50 millisiemens plus 20 millisiemens and angle of negative 90 degrees. So this is equal 53.85 millisiemens and angle of negative 21.8 degrees. This is my total admittance. Next, we're supposed to find I total. I total is equal voltage source over Z total. But someone can say that we didn't find Z total yet. But you're supposed to remember that Z total is nothing else, just 1 over Y total. And we found Y total. So I can rewrite this as voltage source over 1 times Y total over 1, which is equal to voltage source times Y total. Okay, this is the Ohm's law for current, but instead of impedance, we are going to use admittance. So I have voltage source, which is equal to 12 volts, times the total admittance, 53.85 millisiemens, and angle of negative 21.8 degrees, is equal 646.2 milliamps and angle of negative 21.8 degrees. So this is my total current in my circuit. Next, I'm supposed to find the current which goes through the inductor. In order to find the current which goes through the inductor, I'm going to use current division law or current division formula, okay? So I'm supposed to write IL is equal I total times BL over Y total. Okay, this is the current division law for this circuit, and instead of impedances, this time we are going to use admittance and the susceptance. So I have I total equals 646.2 milliamps and angle of negative 21.8 degrees times BL, which is equal 20 millisiemens and angle of negative 90 degrees, over Y total, which is equal 53.85 millisiemens and angle of negative 21.8 degrees. This is equal 240 milliamps and angle of negative 90 degrees. Again, I did this long way, just make you practice the current division law. Next, we're supposed to find voltage across the resistor. Don't forget that we talk about the parallel circuit, right? So voltage source is going to be equal to the voltage across the resistor, and is also going to be equal to the voltage across the inductor. Okay? And everything is equal 12 volts. Power factor. Formula for power factor says PF is equal cosine of angle theta. Okay, so I have cosine of angle which we have next to Z total, we used to say, right? But at this moment we do not have Z total, so which angle are you supposed to use? You're supposed to take the angle which is next to Y total. Okay, so if I have Y total, you're supposed to use the one which is next to Y total. So you're supposed to write minus 21.8 degrees. Okay. Now what you're supposed to realize that you can use the angle which is next to Y total or Z total. The difference is only the angle, but in our case it's not going to give us any difference if it comes to the final answer. So that's why you can use the angle from Z total or Y total. So I have answer 0.928, and I'm supposed to say lag. Why lag? Because we are talking about the circuit which contains the resistor and inductor, right? Anytime we have inductor, the current is going to lag. Please notice that I total has angle negative 21.8 degrees, right? It means that it's lagging the voltage source by this angle. That's why I have word lag. Next, I'm supposed to find the reactive power, QL. QL is equal 1/2, because I'm using peak value of voltage, 1/2, and I have IL raised to the second power times the X of L. Someone can ask why I'm using the formula for power which has current instead of voltage. The whole purpose of it is just to make you practice. You're supposed to be familiar with the formulas which contain voltage or current, okay? So I'm going to have 1/2 IL. We found IL is equal to 240 milliamps raised to the second power times X of L, which is equal 50 ohms. So QL is equal 1.44 volt amp reactive. And this is the reactive power in my circuit. Next, we are going to find the apparent power. Okay, so always write the formula first. S is equal 1/2 I total square times Z total. Okay, now, so I have 1/2 I total is equal 646.2 milliamps, okay, raised to the second power times Z total. But as you remember, we didn't calculate Z total, but we found Y total. So I'm supposed to simply write, instead of Z total, 1 over Y total. Okay, so let me rewrite this one more time. So I have 1/2 646.2 milliamps raised to the second power times 1 over Y total, which is equal 53.85 millisiemens. Okay, so apparent power is equal 3.87 volt amp. Okay, so this is the apparent power in my circuit. Next, I'm supposed to find the equivalent series circuit. So we always say that we're supposed to find Z total. Okay, but again, we didn't find Z total, but we found Y total. Why I'm doing that? Just to make you see that there are many different ways to solve the problems like this. So we have 1 over Y total. So I have 1 divided by Y total is equal 53.85 millisiemens, an angle of negative 21.8 degrees. Now, I want you to switch your calculators to the rectangular mode, right? And just press equal. You're supposed to obtain the value, right, of Z total in rectangular form. And you're supposed to get 17.24 ohms plus J 6.89 ohms, where this is your resistance, RS, and imaginary part is your inductive reactance, X of L, S. Next, we're supposed to find the inductance of the inductor in the series equivalent circuit. We have a formula which says X of L is equal omega L. Of course, you're supposed to remember about J or angle 90 degrees, but right now we don't need that because we're looking for L. We have given X of Ls, we have omega, and we have to find Ls. So, solve this formula for Ls. So you have Ls is equal X Ls over omega. So I'm going to have X Ls 6.89 ohms divided by omega, which is equal 1 times 10 to the 6 radians per second. This is equal 6.89 microhenries. Okay, so this is the inductance of my inductor in series equivalent circuit. So we have voltage source, we have resistor, we have inductor. So voltage source, don't forget, is equal 12 sine omega t, and I have Rs equals 17.24 ohms, and inductance Ls equals 6.89 microhenries. So we can say that the problem is solved.